Alright, so in our last video we were finishing up with number 5 and we were talking about positive 2 right here, that the limit from the left doesn't equal the limit from the right, so there's a discontinuity right here at 2, and so at 2 we're going to say that it's discontinuous. Alright, then for number 6 they ask us to take the derivative. So we have secant of 2x squared. Alright, if you take the derivative of secant anything, then that's going to be secant tangent of that thing. Alright, so the derivative of secant anything is secant tangent of that thing. That's the derivative of the outside. Then I need the derivative of that thing, the derivative of the inside. So the derivative of 2x squared is going to be 4x. And that's my whole answer for number 6. All right, for number 7, if you take the derivative of anything to the 4th power, it's going to be 4 that thing to the 3rd. So the derivative of anything to the 4th, you pull the 4 out in front, 4 that thing, and then reduce the exponent by 1. So 4 that thing to the 3. 4 that thing to the 3. And then we're going to take the derivative of the inside function, the derivative of that thing. So the derivative of cosine is negative sine. So that's going to give us a negative 4 cosine cubed sine x. Now, you can write cosine cubed just like up here. You can write cosine x to the 4th like this or like this. So the same thing, you could write your cosine x cubed like this or like this. Either one would be perfectly fine. Alright, then for number 8, we need to find a way to rewrite this with an exponent. So remember that when you have a radical, you can write that with a rational exponent, where your exponent is your numerator and your index is your denominator. So again, your index is what tells you if it's a square root or a 4th root or a cube root or whatever. So for this guy, my exponent would be 3 over 2. So I'm going to rewrite that as 2x minus 1 to the 3 halves, and then I can just use power rule. Alright, so for power rule, anything to the 3 halves is going to be 3 halves that thing to the 1 half. Because again, we pull our exponent out in front and then we reduce that exponent by 1. So 3 halves minus 1 would be 1 half. So anything to the 3 halves is going to be 3 halves that thing to the 1 half. That's the derivative of the outside. Then I need to take the derivative of that thing. So the derivative of the inside. Derivative of 2x minus 1 would be 2. So if I take 3 halves times 2, that's just going to give me 3. And you can write this as 2x minus 1 to the 1 half, or you can rewrite it as a radical, and it would be the square root of 2x minus 1 times that 3. Either way you write that is fine. Okay, then for number 9, we're going to find the derivative implicitly. So remember, when we do that, you take the derivative as normal, but anytime you take the derivative of y, then you have to leave a dy dx in there. Alright, so the derivative of x to the 4th is going to be 4x to the 3rd. This is a product, so I'm going to have to do first times derivative of second plus second times derivative of first. Alright, so first is negative x times derivative of second. The derivative of y is 1, and since it's a y and it's not in terms of x, I have to leave a dy dx in there. So first times derivative of second plus second y times derivative of first. So the derivative of negative x is negative 1. That is in terms of x, so I don't have to leave a dx in there. Then I'm going to come over to the other side. The derivative of y cubed is going to be 3y squared, and I'm going to leave a dy dx in there because, again, I took the derivative of y. And then the derivative of 4 is 0. Next, I want to get anything that has a dy dx in it on the left-hand side and everything else on the right-hand side. So this first term does not have a dy dx in it, so I'm going to subtract it over to the other side. This negative x dy dx does have a dy dx in it, so I'm going to leave it on the left. This negative y does not, so I'm going to add it to the other side. And then this 3y squared dy dx does have a dy dx in it, so I'm going to subtract it to the other side. So now everything with a dy dx in it is on the left-hand side, so that I'll have a common factor of dy dx that I can factor out. So take out the dy dx out of this, and you'll have negative x left. Take the dy dx out of this, and you'll have negative 3y squared left. If you put your finger over the dy dx in each case, you'll be able to see your other factor. All right, so now to get dy dx by itself, divide both sides by that other factor of negative x minus 3y squared, and that will be my derivative. So there it is right there. And then if you would rather, you can divide the top and the bottom by a -1, or multiply the top and the bottom by a -1. Every one of your signs would change. Either one of those is perfectly fine. They're both the same thing. All right, then for number 10, we're doing particle motion. And so you need to know that velocity is the first derivative. So I'm going to go through and take the first derivative of t cubed minus 27t using my power rule. So let's pull the 3 out in front. So that would be 3t, and then reduce our exponent by 1. So 3t squared. And then the derivative of negative 27t to the first, 1 times negative 27 would be negative 27t to the 0, and t to the 0 is 1. So negative 27 times 1, or negative 27. All right. They also asked us to find acceleration. Acceleration is the second derivative. So the derivative of 3t squared, bring your 2 out to the front. So 3 times 2 is 6t to the first. And the derivative of a constant is 0. Then they asked for jerk. Jerk is the third derivative. So if we take the derivative of 6t to the first, then that's just going to give us 1 times 6t to the 0, and t to the 0 is 1. So I'm going to get 6 times 1, or 6. Then they ask for the velocity at 2. So let's go back to our velocity equation right here, and let's put 2 in for t. So that would be 3 times 2 squared minus 27. So order of operations, 2 squared is 9. 2 squared is 4. 4 times 3 is 12. And so we will have 12 times 27, which is negative 15. All right, then they want to know where the particle is moving forward and backward. It's moving forward wherever velocity is positive, and it's moving backwards where velocity is negative. So let's make a sign graph for velocity. To do that, I'm going to need to set velocity equal to 0. So velocity was 3t squared minus 27. Let's add 27 to both sides, and then divide both sides by 3, and I'll get t squared is equal to 9. Take the square root of both sides, and t will be plus or minus 3, because when you insert a square root, you always insert a plus or minus. So here's our sign graph for velocity. We have a 0 at -3 and a 0 at +3. All right, so let's pick a test point. I'm going to pick 0, and since I'm trying to figure out where my velocity is positive and negative, I'm going to plug that test point of 0 back into my velocity equation. So when I put 0 in for t, I'm going to get t squared is 0, 3 times 0 is 0, and then minus 27. So I'll get a negative 27. So at 0, my velocity is negative. When you cross a single root, the sign changes to positive. Cross a single root, the sign changes to positive. Or you can do another test point over here at like 4 and another test point over here at like -4, and you'll get a positive in each case. All right, so there's our sign graph. So that means that from -infinity to -3, this was moving forward. From -3 to 0, from -3 to +3, this was moving backwards. And from +3 to infinity, it was moving forward again. Now, if they tell me something like, we only want to give the values in the original problem where time is greater than or equal to 0, then I would just say from 0 to 3 it was moving backwards, and from 3 to infinity it was moving forward. All right, then we want to know where it's at rest. It's at rest where my velocity is 0. So we have already found out where the velocity equation equaled 0. That was at 3 and -3. So we know that it's at rest at 3 and -3. And then last, I want to know where it's speeding up and slowing down. And so I need to know, to be able to compare my velocity and acceleration, I need to know a sign graph for acceleration. So let's take acceleration, which is 6t, and set it equal to 0. Divide both sides by 6, and we find out that the only root is going to be at 0. So let's make a sign graph for acceleration. I'm labeling these so I can tell which is which. And there's my root at 0. So I'm going to pick a test point of +1. If I want to know where acceleration is positive and negative, I plug that test point back into the acceleration equation. So if I plug in +1, I'm going to get a +6. So acceleration is positive over here. Cross a single root, the sign changes, or you can pick a test point over here of like -1 and plug it in, and you can see I'd get -6 for that, so it's negative over here. So anywhere velocity and acceleration have the same sign, then it's speeding up. Where they have different signs, it's slowing down. All right, so if you'll notice, from -infinity to -3, this was positive and this was negative. Their signs were different. So from -infinity to -3, it's slowing down. Then from -3 to 0, this is negative and this is negative. So from -3 to 0, it's speeding up. Then from 0 to 3, 0 to 3, this is negative and this is positive. So it would be slowing down from 0 to 3. And then from 3 to infinity, this is positive and this is positive. So from 3 to infinity, it's speeding up. All right, and then for number 11, we want to know the marginal cost. So marginal just means derivative. So when they give me the cost equation, all I have to do is take the derivative. So the derivative of a constant is 0. Then power rule here, derivative of -6x cubed, bring our 3 out in front. So 3 times -6 is -18. Reduce our exponent by 1, so that would be x to the second. And then 5x to the fifth, we bring our 5 out in front. So 5 times 5 is 25, x to the, reduce the exponent by 1, so 25x to the fourth. So that would be our marginal cost. And if they asked us to find the marginal cost at a particular value, I could plug that in. That is the rate of change of my cost. So that is just the cost of 1 unit at that production level. So if they said find the marginal cost at 100, and I plugged 100 into this, that would tell me the cost of making each individual unit when I'm making 100 of them. All right, then for number 12, we want to find the derivative of the inverse. All right, so they tell me that my function is x cubed, and they want me to find the derivative of the inverse at 8. All right, so to do that, this is the formula that I have to know. All right, so I can go through then and say, first off, I need to find g of 8. All right, so if I want to know what g of 8 is equal to, that's going to be the ordered pair 8 something. Remember that on the inverse, x and y switch places. So since they've told me g is the inverse of f, whatever this is, 8 something, would be something 8 on the original. So for instance, if this was the point 8, 2, then this would be the point 2, 8. So if I can figure out where my function is equal to 8, that will tell me this value, which would be the same as this value. All right, so I'm going to set my original function equal to 8. So my original function was x cubed. So let's set x cubed equal to 8. Take the cube root of both sides, and I'll get x is equal to 2. So if this is the 0.28, this is the 0.82.